So piecewise functions are several pieces of a function put together. So it might be two lines that you put together. It might be a parabola and a line. It might be an absolute value and a parabola. It's just lots of different pieces that you put together to make a function. There is lots of real-world situations where piecewise functions are used. We won't spend a lot of time on them, but sometimes, like cell phone plans, and I'll explain what that means, but cell phone plans is a time that piecewise functions are used. Mileage and salary is another way that real life piecewise functions are used. And let me explain. So like cell phone plans right now, you have a lot of you probably have unlimited data. But before you had unlimited data, or maybe even if you don't have unlimited data, it's free up to a certain point. It's just the charge of the phone. Maybe you're paying $20 a month for your phone, and as long as you don't go over your data, it's just that $20. But if you go over your data, it's like 3 cents for every gigabyte or something like that. That's a piecewise function because at first it's just this standard price, but then at a certain point it changes and the price starts going up after a certain point because of going over the data. So that particular function would be like flat, and then it would go up like that, and that's a piecewise function. Mileage and salary, like for example, if you work at a job where you get a certain amount of money for the mileage that you drive, plus you get your normal just charge per month. So maybe like you get, I don't know, making this up as I go, but let's say you get $2,000 a month for whatever job it is. Plus you also get mileage because maybe you sell things. And so your price is the $2,000 per month, but as your mileage increases, your salary would increase as well, because you would get a little bit more for the mileage that you took. And so the way those change, those are piecewise functions. And it's just different types of functions that are added together. So that's examples of real ride and why we need it. But let's talk about how we actually do it. So first of all, before we go into some piecewise function, let's just look at a normal function, f of 2. It says, here's f of x, find f of 2. Well, if it tells you to do that, all that means that you're going to do is plug in 2 into the equation. Just like with absolute value, how you can evaluate, you can do it the same way. You're going to plug in a 2 for every x. If there's 2 x's, that number goes in for every x. So you'll have 2 times 2 squared minus 3 times 2. And then you just solve. Now, you can put that in Desmos, or you can put it just in your normal calculator in your phone, whichever way you want to. Or if you just work it out and you know your operations pretty well, then you can do it that way. But 2 times 2 squared minus 3 times 2 is 2. Same thing will happen if you wanted to evaluate f of negative 1. You would put a negative 1 in the x place. This one is just a tad bit tricky because you have to be careful how you square that negative 1. I do want you to realize that if you put negative 1 squared, and if you put negative 1 in parentheses and then squared, those two things give you a different answer, okay? Negative 1 squared here means you're squaring the negative 1. You're doing negative 1 times negative 1. That's why you get a positive. Up here, that means square the 1 and then just put a negative on it. So those two things mean differently. So make sure when you do this one that you put it in correctly. It's actually asking you for the second one. So if I were going to do that, I would put 2 and then the negative 1 squared minus 3 times negative 1. And in that case, we get 5. So that was just a little side note about evaluate functions, because to be able to evaluate piecewise functions, you have to evaluate just normal functions. Okay? All right. So piecewise functions, it's similar, except you have to look at the domain of the function to decide where to plug it in. Okay? Let me explain what that means. So here's f of x. F of x is 3 if x is less than or equal to 0. F of x is 2 if x is greater than 0. So in number 1, it wants me to find f of 2. So what I have to do is I have to come up here to the x and I have to figure out, is 2 less than 0 or is 2 greater than 0? Well, 2 is greater than 0. So I'm going to plug in 2 for any x that I see. There's not any x. It just tells me it's 2 if that's the case. So that means that this answer is 2. So you figure out where it falls, and then you plug in or evaluate based on that. Okay? Let's look at another one with f of x. It says f of negative 4. Alright? Negative 4 is not greater than 0. It's less than 0. So negative 4 is going to go right here, which means f of negative 4 is 3. Okay, f of 0, that one's just a tad bit trickier, because when you look at the way it's evaluated here, we've got less than or equal to 0 and we've got greater than 0. Well, it's not less and greater, it's actually equal to, so you're going to pick the one that's equal to 0. This one's equal right here. So that means 0 is going to fall right here, which means that 3 is the answer that I'm looking at. I'm going to minimize Desmos a little bit, make it a little bit bigger for us. Okay, then the last one says f of a half. Alright, so a half is greater than 0, not less, because less would be negative, so it's greater than 0, which means a half is going to go here. So our answer is 2. Now when we were talking about f of x, it was just 3 and 2, and our answers were going to be 3 and 2. Let's look at one where you actually have to plug it in. Okay? So these right here, they all say g, so I'm looking at this function g. Okay? So g of 7. Well, 7 is not less than 3, it's greater than 3. So 7 is going to go right here, and I just plug it in. 2 times 7 minus 1, which is 13. So these you actually evaluate. You just figure out which one it falls into, and then you evaluate it. So this one says g of 0. So 0 would be here. So I'm going to plug it in there. So I would have 0 plus 5, which is 5. Alright. G of negative 1. Alright, so it's negative, which means that's going to be less than 3. So again, I think we're looking at that very first one. So we'll have negative 1 plus 5. We just evaluate that and get 4. Next it says g of 3. So 3 is here because that's where the equals is. So again, we're still working at that first one. Plug in 3 for x, so we get 3 plus 5. Alrighty, let's look at h real quick. So h of negative 4. Alright, so we've got less than negative 2 and greater than negative 2. Well, negative 4 is less. Think about the number line and how it's below. So that means that negative 4 is going to go right there. So I'm going to have 1/2 times negative 4 minus 4. Again, you can use Desmos if you want to. I do believe you get negative 6 there. Alright, this one says negative 2. Negative 2 is equals. So that means it's going to go on this one. So we'll have 1/2 times negative 2 minus 4. So that'll be negative 1 minus 4, which is negative 5. Number 11, h of negative 1. All right, negative 2, negative 2. Okay, we know that negative 1 is greater than negative 2 because it's on the number line, it's above it. So that would be on that one. So we'd have 3 minus 2 times negative 1. So I think that's 3 plus 2, which would give me 5. Like I said, I'm evaluating those in my head. You can use your calculator, no big deal. H of 6 I know is greater than negative 2, so 6 would go right there. So we'll have 3 minus 2 times 6, 3 minus 12, which is negative 9. So here's the answers on 13 through 18. Just be careful and make sure you're plugging it into the right equation. So when you're using a graph and you're trying to evaluate the function, you're going to look for the y value. Okay? The value they give you is the x value, and you're always looking at what the y value at that place. So the first one says f of 0. Alright? So I go to the x at 0, and then I try to figure out where is the function. Oh, the function is down here. It's down here at this value. And I just write down whatever the y is. Negative 1, negative 2, 3, 4, 5. So this one is negative 5. So you find wherever that function is all over the graph somewhere, and then you find it from there. So next one says f of 1. Alright, here's 1. And I go all the way up and down 1 to figure out where it is. When you see an open circle like that, that means that it's not that value. It never gets to that value. So this is not anything. It's not included. Okay? F of 1 is actually included down here where that closed circle is. And again, that one is negative 5. Just remember the open circle is not a value, so that's not the answer. Alright, next it says f of negative 5. So that means that I go to the x at negative 5, and I find the y value at wherever it is. Well, in this case, it's up here, and that y value is 2. Okay, next it says f of 3. So I go to the x-axis at 3, I find the y value. Looks like it's also 3 because it's up 3. Alright, next it says f of negative 3. So I go to negative 3. It's an open circle there. That's not the answer. So I try to go around the function somewhere else. It must be this value down here, which is also negative 5. Alright, f of 5 means go to 5 on the x-axis. Find the y value, which is up here. So 1, 2, 3, 4. So f of 5 is 4. F of negative 2. So we go to negative 2. Go down here where the function is, evaluate it. Still negative 5. There's a whole bunch of negative 5s. And then lastly, it says f of 6. So I go to 6 on the x-axis, and I find the value of the function. There's nothing there at 6. If that happens, that means that it's a no solution. There's nothing there. You could say does not exist, or you could put the 0 with the line through it, which also means no solution. So f of 0, you don't move anywhere on the x-axis. You just go to wherever the function is evaluated. So it's up here on the y-axis at 2. So that's 2. Now the most tricky one, I think, from looking at what you guys have is maybe f of 1. When you go to 1 on the x-axis, it stays right there. It doesn't move up or down or anything. So it's just that value right there on the x-axis. If it's on the x-axis and you've not moved up and down any, that means that it's 0. So f of 1 is 0 because that's the y value at that place. F of negative 5 means that I go over to negative 5 and then I find the y value down here, which is negative 4. Alright, f of 3, that means I go over to 3 and I find the y value. There's nothing there, so this is no solution on f of 3. Alright, f of negative 3, so I go to negative 3 and I find the value. It's here at this closed circle. It's not the open one, but it's the closed one, so it's that value there, which comes out to be negative 1. Alright, f of 5. I move over 5 and I find the value. Oh, it's up here. It's beside that open circle. So it's wherever that is. So 1, 2, 3, 4, 5, 6, 7, 8. Alright, a couple more. F of negative 2. Go over to negative 2. It's this value here where it is on the y, which is negative 1. And then f of 6. 1, 2, 3, 4, 5, 6. Find that value. It's the same one that it was for the 5. So it's still 8. So f of 0 is 3. F of 3 you move over on the axis is 0. F of 5 is 2. And then f of 1, you go up as 1. F of 2, there's two values here, but it's the one with the closed circle, so that's 3. And then f of 4 is on the y, so it is 4. Now, I want to show you real quick. You can actually graph these in Desmos. I don't know if graphing it is the way that you would want to go. I do believe you do not need to graph it, but if you want to know, I want to show you real quick. So let's pull that up, and I'll just explain the instructions and graph one of them for you. That way, if you ever have to do it and you really want to know how, you can. So you start off by putting these little bracket things, and on the keyboard, it's beside the P. So there's the bracket. Then you put X is greater than, and you put the equation, X plus 3. And then you also have to put comma, I believe X is less than or equal to 0. So there's one part of the equation if I'm putting in 23. Okay. If I need to put in 24, I still go to shift and those little bracket things again. And it says, if you look at the instructions, it says X is greater than, and then the equation. So I'm still putting X is greater than, if I didn't put X. There we go. And then we put the second equation, comma, X is greater than 0, and that's not correct. That was wrong. Put it backwards. This should have the greater than part, which is 0, and I didn't put the colon, sorry. Colon, and then the equation. Backwards. There we go, that's correct. Except that's not the right equation. Again, sorry, this is all confusing. This is why I don't think you would want to graph it. Let's start back again. This one is going to be the less one, because it says less than or equal to, and it's less than or equal to 0, and then the colon, and then the X plus 3. Sorry about that. There's the graph. So that's the graph for this equation right here. The question wants me to evaluate f of negative 2, f of 0, and f of 2. Do I want to use the graph, or do I just want to use the equation? I think the equation, because the graph is too confusing to figure out how to put in Desmos. Obviously, I can't even figure it out myself, even though I know what I'm doing. So I would think that if they give us an equation, let's just use the equation and don't worry about the graph. Okay? So, we're going to put Desmos down and just, even though it says graph it, we're just going to evaluate it. So we take this -2. I know that it's going to be on the less one. And so I'll have -2 plus 3, and that would be 1. For f of 0, it's the equals one. So 0 would fall right here. So again, that would be 0 plus 3, which is 3. And then for f of 2, I know it's greater than 0. So I'm going to put a 2 right there, and I would have 2 times 2, which is 4. Now, I wanted you to see 24 real quick, just so that you could see sometimes it's not just 2 equations that they have for the piecewise function. There's 3 equations. You do it the same way. You still use the restrictions they give you to figure it out. But let me just show you that real quick. So f of -2. So -2 is less than 0. So I'm going to plug it still into that one. So -2 plus 1, which is -1. All right, f of 0. This one says less, and this one has a greater, but there's an equal, so it must be this one that I put it into. So that would be -0, which is just 0, plus 1, which is 1. All right, f of 2. All right, 2, there's the equal on the 2. So the 2's got to go on this one. So it's going to be -2 plus 1, because I just have to put a negative in front of it. And then the last one is f of 4. 4 is greater than 2, so 4 would fall here. So 4 minus 1, which is 3. I just wanted you to see what that would look like if there were 3 equations, but it's the same process. All right, last question. This is a question to talk about what a real-world situation would look like. So this says that we have a trip. The distance in miles you travel is in X hours is represented by this function. So whatever we get whenever we work out something is the distance, but the X values that you plug in would be the hours. So if I want to figure out how far I travel in 1.5 hours, I just have to figure out where 1.5 falls. 1.5 falls here. So in 1.5 hours, I'm going to travel 82.5 miles. For 3 hours, 3 is still in that range because this means between 1.5 and 4. So 3 is still in that range, and that would be 82.5. 4.5 hours is greater than 4, so 4.5 would go here. So that would be 82.5 plus 320 times, instead of X, we're going to put that 4.5 there. And to make sure I don't mess up, I'm going to put that one in Desmos. So 82.5 plus 320 times 4.5 minus 4. And you get 242.5 miles.